Hi, my name is MOHAMAD THAQIF, and today I'm going to present what is first order ordinary differential equation. But before you know what is first order ordinary differential equation, you need to know what is ordinary differential equation first, also known as ODE. So ODE is differential equation that contain derivative and have two of these characteristics, which are: firstly, it contains one or more dependent variable. Second, with respect to one independent variable, such as example like this, y is dependent variable which depend on one independent variable, which is x. So, what is first order ODE? So, the order of the differential equation can be determined by the order of the highest derivative involved. Then, first order ODE is the differential equation that contain only first derivative like dy dx as the highest derivative involved. Furthermore, there are several types of first order ODE, but in this video we are going to talk about specifically inseparable equation and one of its application.
Okay, from the 5 type of first order differential equation, which is separable equation, homogeneous equation, exact equation, linear equation, and Bernoulli equation, our group choose to do one of it, which is separable equation. So what is separable equation? Separable equation is a differential equation is any equation that can be written in the form. Okay, next step to solve a separable equation. Next is application of separable equation. This is the example, which is population growth, heat flow, and radioactive decay. So our group choose to do a radioactive decay. As you can see, that is what is radioactive decay is. It has a 3 element.
One day, a scientist found a fossil in a fossil site. Then, he decided to determine the age of the fossil, but how should he do that? He can use the rate of decay equation dn equals to negative lambda n dt, which is a separable first order ODEs, to determine the age of fossils. It is given that Nt is equal to the number of nuclei remain at time t, and lambda is equal to the decay constant. Find Mt if the sample contains 4 times 10 power of 10 carbon-14 nuclei initially. The decay constant of carbon-14 is 3.835 times 10 power of negative 12 per second. Then, find the age of the fossil if the carbon-14 nuclei drop to half.
Okay, thank you, Kaiwei. Now we continue to the solutions of these questions. So, in the initials, which is the t equal to 0s, the n naught is given by the question is 4 times 10 power of 10. So, n naught equal to this, and the constant is also given by the questions. So the constant is this, and the question asks the half for the time needed for the carbon-14 nuclei drop to the half, which means that the amount of the initials drop to the half. So how many times is needed? So we have this, we need to find the times needed. So for this question, the first steps, we can get the equations. So dn equal to negative lambda n dt. So we need to use the separable equations to solve these questions. Then we integrate both parts, we will get n and then t plus c. Okay, so from these questions, these have a mistakes. Okay, now we can substitute the information given. So when t equal to 0, the n naught equal to 4 times 10 power of 10. So this can be write in like this. So when t equals to 0, so it's a c. Yeah. So c equal to this. So our equations become this times t plus 4 times 10 power of 10. The next is the lambda is given, so actually we can lambda is given, so we can write like this. Yeah, so the equation is almost complete. So we can, from the question given, when the n's become half of the originals, so we can write like this: n notes half of the originals, and then t plus this. So n naught is given, so we can continue with to write this equals to 2, and then equals to 3, this, and then 3 plus, continue with the constants. Okay, next steps, actually we can become this. We move the ln to the left hand side. Okay, so the ln, so the 4 times 10 power of 10 is divided by 4 times 10 to the power of 10. It will become ln 1 over 2 is equal to negative 3.835 times 10 power of 12t. So we move the constants to the left hand side. We will get t equals to 1.8074 times 10 power of 11 seconds. So to convert the second, because at the questions is a very important part, the questions need the age of the fossil. So now we need to convert it into the years. So to convert it into the years, we need to divide it by 60, 60, 24, 365. This, the first 60 is about the seconds. Second 60 is about minutes. The third, the 24th is about the hours, and 365 is about the years. After we divide this, we will convert it. Convert it into the years. So the answer is 5731 years. 5,731 years. So this approximately. So yeah, we have finished this question. Thank you.
Hello everyone, my name is Ying. I'm going to explain about the problem statement 2, radioactive decay of beryllium. Radioactive beryllium is sometimes used to date fossils found in deep sea sediment. The decay of beryllium satisfies the equation dy over dx equals to negative ky, where k is equal to 1.5 times 10 power of negative 7 and t is measured in years. So now, how can I determine the half-life of beryllium? As a reminder, half-life is the time required for half of the radioactive nuclei present in a sample to decay. Let us try to solve the question.
So thank you, Ying. Now we continue with the solution of the second question. Now the constant given is 1.5 times 10 power of 37 per year. Now the first step is same like the solution 1. Usually we can get the equations from the questions, and then the next step is we need to make the equation come out. So how to do this? We can use the separable equations method. we integrate both sides, we will get this, will get ln y equal to negative k d plus c. C is the constant. Now we move the ln in the left hand side into the right hand side, so it will become this e power of negative kt plus c. So from this we can notice that ec is actually a constant. We let it become a. So y equals to a e minus k t. So from the question given, he wants us to find the half-life. So first we need to complete this equation first. We haven't get all of the informations. So when t equals to 0, which is the initials, y equals to y naught. Y naught, this is mean that the initial value. So y equals to when when t equals to 0, the power becomes 0. So y equals to a. So we can replace the a by y naught. Okay, this is not the concept of naught because it is the initial value. Okay, so we write this. So the constant is given, so we can substitute into the k, negative 1.5 times this t. So what they want is the half-life. What is the half-life? Half-life is the time needed for the half of radioactive nuclei present in the sample to decay. Half of it. So when y equals to half of the initial value, okay, so t is equal to 1. Okay, so y equals to, okay, y naught over 2 equals to y naught e negative 1.5 times 10 power of 7t. So we move the y naught in from the right hand side to left hand side, it will become this. So then we can continue to move the e to the left hand side, it becomes lns, and yeah, like this. And then we can solve this by using the calculators, and we will finally get this answer. So that's it for this question. Thank you.
Thank you to group members. We finally reached the end, but before that, I would like to make a summary of this video. First order ordinary differential equation is quite uncommon to use in our daily basis, like reading, exercising, or even doing laundry. However, it does serves its function for certain application like determining the age of a fossil and a radioactive decay of beryllium, as demonstrated in this video just now. We might haven't noticed this, but who knows that a separable equation can be utilized as a researching method to gain more information in the aspect of science and technology. As engineers, we might apply this kind of concept in real-life jobs, so it is essential to learn this to sharpen our analyzing skill later on. So this is our references upon making this video. That's all from us. Thank you.